Yes, good morning all. So let's start operating system. So I think on Tuesday we have completed algorithms which are page replacement algorithm, and when page fault occurs, then how operating system will decide which page should be out from the memory to accommodate new page which is required. So we have seen, I think, optimal page replacement algorithm, NRU, not recently used page replacement algorithm, FIFO, then second chance, then clock page replacement algorithm, and LRU, least recently used page replacement algorithm. And we have seen one example also, so that you can have that idea. So I think the topic is over. So one concept is remaining uh, as far as this chapter is concerned, which is you can say segmentation, and then we'll finish this unit today, and we'll also start the new unit today itself. So I think let's start. So the last topic is segmentation. So most of you might be aware that the name segmentation means dividing something, right? Dividing something into the smaller parts. So first we'll see what is segmentation, why segmentation, and how it is different than virtual memory, which is paging, right? So basics of segmentation is, for many problems, having two or more separate virtual address spaces may be much better than having only one. So just now, we have seen that virtual address space, right? Why virtual address, how it is mapped with physical address. But the example that we have seen that there is only one virtual address space. I think we have seen from 0 to 64K, right? Virtual address, and physical 0 to 32K. So what it is telling that for many problems, so it is not for all, but many, having two or more separate virtual address spaces may be better than having only one. So rather than having only one address space, virtual address space, the idea is to have more than one separate virtual address space. So the address space which we have seen is just one, 0 to 64K. But rather than having one, what if we will have multiple such address spaces? Each of these address spaces are separate than each other, right? So and what will be the benefit? Let's see. First, let's take the example. For example, a compiler has many tables that are built up as the compilation proceeds, probably including. See, in your higher semester, I think in 6 or 7, you will learn a subject called compiler design. So compiler design, in that subject, you will understand when you compile a program. Let's take simple example of a C program. When you compile a program, what the compiler may do. Now, I hope you are very much aware what is compiler, right? Which is compiling your program, which convert your source code to the object code, as well as it will check the syntax and semantic errors. So when you compile a program, what it will do, or your program will be divided majorly into the 5 different parts. Now these 5 parts are the source text being saved. First, your source program, the program which you have written, source text, right? Source code in simple language, source text or source code. Symbol table, one separate table will be made, which is symbol table containing the names and attributes of the variable. So all the variable that you have used in your program, a symbol table will contain the name and attributes of that variable. This is number 2. Number 3, the table containing all the integer and floating point constants which are used. Now, I will not explain over here what is variable and what is constant, right? So, all the integer and float constant will be stored in separate table. So, compilation is nothing but you can see from this example that dividing, or you can say decomposing your program in different part. First is source text, second is symbol table which contains variable, and the third one is integer and floating point constant. Fourth, the parse tree, because see, few words you may not understand over here, but when you will learn CD subject, which is compiler designing, at that time you may learn. So the parse tree containing the syntactic analysis of the program. Now let's take example of C only. In C, you need to follow some syntax, right? So the syntax analysis of the entire program will stored separately. And the last, the stack used for procedure calls within the compiler. If your program is having any user-defined process or any system-defined process means function. If there are any procedure call or a function call, then it will be saved separately. So your program will be decomposed in these, you can say, subpart. One is the entire source code, a separate symbol table for list of variable and names, a table with all the constant or the integer and floating point constant, parsing tree, which contains syntactic analysis, means syntax wise your program is correct, the analysis of the same, and the last one, the stack, which is used for procedure calls within the program. So these are the 5 categories. Now you can see that if we are having a single virtual address space, right? So all this thing for a single program will be stored in a single virtual space. For example, symbol table, source tag, constant table, parsing tree, and stack. Now if you see few, for example, these are address space allocated to the parse tree. This is free. So space currently being used by the parse tree, right? This is the currently space used by the parsing tree, and this is free. So in the some case, some space is free, that means wasted. But for example, symbol table, now you see symbol table, what it contains, variable. So sometimes if you use more in, for example, dynamic array, now you don't know how many values you are going to store in array. So some portion is be allocated for the symbol table, but the symbol table has bumped into the source table, because when your program start running, see, and we are not talking about the small programs that you are making, we are talking about the programs of 1,000, 2,000, 5,000 and 10,000 of lines, right? So such bigger programs, see, when the program keep ahead, the symbol table, the number of values or number of, you can say, variable will increase. So the space is not enough. and for example the source symbol table is bumped, and it will be override the source text portion due to lack of space. Now you can see it is a linear addresses, some space is free, or you can say wastage of the spaces, but here due to the lack of spaces this problem may occur. So this problem occurred because you are having a single virtual address space. Now you might be having the idea what to do, right? The solution is to provide the machine with many completely independent address spaces which are called segments. Now we are coming to the segmentation. So what is the solution of this? Because when you are growing, then if you are having a single address space, then your portion of your program will be override or overlap with the other portion. So the solution is, let's provide the machine with completely independent address space which are called segments. So each segment consists of linear sequence of addresses starting from 0 and going up to some maximum value. So rather than having a single address space, let's have multiple address spaces all starting with 0 up to some maximum. Segment length may change during execution. The segment length can be vary during the execution. The length of the stack segment may be increased whenever something is pushed into the stack and decreased whenever something is popped out of the stack. So you can say it's flexible. It can be increased. It can be decreased dynamically by the operating system and memory management unit. So each segment consists of a separate address space. Different segments can grow and shrink independently without affecting each other. Now you are having a separate address space. So each segments are separate within the program. So the segment consists of separate address spaces. Different segment can grow or shrink independently without affecting each other. A segment can fill up, but segments are usually very large, so occurrence is rare. Now your question may be, sir, what if segment can fill up? An independent segment can fill up, but so the answer is the segment can fill up, but the segments are usually, so operating system usually allocate the large space. So answer is segments are usually very large, so the occurrence is rare. It will rarely happen that a segment may fill up. Then you may get the error related to some memory references, right? Otherwise, it is very rare. To specify an address in the segment, two-dimensional memory, the program must supply two part addresses. One is segment number and second is address within the segment. Now, earlier you are having only one address spaces, right? So no need to supply the address and segment separately because you are having only one, you can say, single address space. But now each segment are different and all address will start from 0. Now, if you give only one address, then you don't have the idea which this address belongs to which segment. Now you need the segment number. So it will be a, you can say, two-dimensional array where one dimension will represent, just a minute. Hello. So there will be a two-dimensional array. One dimension represent segment number, and second dimensional, the address within that particular segment. So a segment might contain procedure or array or stack or collection of scalar variable, but usually it does not contain mixture of different types. So this is very important to understand. A segment may contain a procedure, array, or a stack or collection of variable, but usually it does not contain mixture of different types. So a separate segment for separate types of data. So this is the idea. Now graphically, see this. This is symbol, for example, symbol table, because it contains variables. So usually the size will be large, and all the you can see that addresses starts from 0. Segment 0 is for symbol table, 0 to 20K. Segment 1, 0 to 12K, it is for the source text. You can see you will need, if you have used a very small constant, so few addresses for constant, parsing tree, segment 3, segment 4, call, which is procedure call. So separate address space, separate. Now the address will contain which segment. For example, 000, 00, all the 0, but which segment? Either 0 or 1 or 2. Now your address will contain two parts. One is the segment number, and second one is the internal address within that segment. Now how it will be implemented? So this is implementation of pure segmentation. You can see there are multiple segment. Segment 0, 1, 2, 3, 4. Right? And each are, this is the size, in bracket size is mentioned, 4K, 8K, 5K, 8K, 7K. Now now it is not like that on your computer is running only one program. It may run different programs. Then the different needs to be in and out to physical memory and virtual memory, right? So now you can see 0, 1, 2, 3, 4. After some time, some segment 7 will come with size of 5K. With size of 5K. Now where to accommodate? Now operating system has decided, let's remove segment 1. Let's remove segment 1. So what is the size? 8K. Now this is 5K. So 3K is unused space, or you can say hole. Right? After some time, consider one more segment, segment 5 will come. So again, operating system will decide which segment to remove. Now, for example, operating system will decide this segment. So total is 7K. Now segment 5 is for 4K. So out of 7, 4 is occupied. So 3 will be remaining. This is unused space. Same way, after some time, one more segment 6 will come. So operating system have decided this segment to go out. So 4K, size of segment 6 or 4K will be unused. So after some time, using fragmentation technique, all the holes can be combined like that. So operating system will combine all the holes by moving, because each of the segments are independent of each other. So just address mapping needs to be changed. So all 0, 7, 2, 6, 5. So operating system have created the larger space, which is 10K. So if the new segment will arrive, no need to disturb the existing segment. They can be accommodated over here. So this is defragmentation. So this is how you can say pure segmentation can be implemented. And the last, this question is being asked many times in the examination. Now you will see what is the difference between the paging and segmentation. We have already seen what is paging, virtual memory, using page table and page frames. and we have just seen segmentation. Now, what is the difference, or what is available in which? So first is, need the programmer be aware that technique is being used? In paging, no. So programmer need not be aware, it is completely task of operating system. But in segmentation, yes, programming need to be aware about the segmentation. How many linear addresses space? In paging, only one. We have already seen 0 to some 64K, but here many different address space for different segments. Can the total address space exceed the size of physical memory? Yes. Answer is yes. That is why we are using paging and segmentation, because the total address space is much more than the size of actual memory which is physically available. Can the procedure and data be distinguished and separately protected? In paging, no. In segmentation, yes. We have already seen that procedures and data, your source code and your data is separately stored in separate segments, so it can be protected separately. Can the tables whose size fluctuates be accommodated easily? Paging, no, because you don't have a separate segments, but in segmentation, yes. Is sharing of procedure between users facilitated? Paging, no. In segmentation, yes, you can share the processes between the users because each process are shared into the different segment. And the last, why was this technique invented? What is the need? So paging, to get a large linear address space without having to buy more physical memory. This was the basic idea for the paging. But in segmentation, to allow programmers and data to be broken up into logically independent address spaces and to add sharing and protection. So this was the idea. So this is the, you can say, comparison between paging and segment, and this question have asked many times into the examination. So that's it. Memory management. Is anyone having any doubt, any confusion? Which then ask me, otherwise we'll start the new unit. So there are no doubts in two cases. One, you might have understood everything. Second, you might understood nothing. Which is the case? Either understood everything or nothing. I want answer from everyone, not just 2-3 students. Once again, please. But what once again? I think I am getting answer from 8 or 10 fixed students. Otherwise, entire segmentation is difficult to explain. If you are having any doubt, then I can explain. If you are doubt any particular concept, then you ask me. Yeah, you can see the video later on, or even you can refer the book Tenenbaum. It is very good book, and easy explanation is given. So the idea is nothing in virtual memory and paging. You are having a single address page which contains mixture of data. All the data, variables, source code, symbols, everything is stored in a single memory. But here in segmentation, the idea is let's divide the virtual memory into different segments, and then each types of data, whether it is source code or procedures or symbols, syntax analysis, let it be stored in different address spaces starting with 0. So it adds security, number one. And if any segment wants to grow during execution of the program, then it can grow easily. So this is the basic idea of segmentation. Just a minute. Sorry. So, any doubt, any query? Sekhar, I think you watch the video, you will get understand. Either you read books. Though, if you have any doubt, you can approach me. I can explain again. So, should we start next chapter? IO management. With your kind permission. Next day. Why Ashish? Next day? Just 20 minutes, sir. 20 minutes. So right now we are having 30 students. So 30 into 20, 600 minutes. Not a good day today to start a new. So everyone agrees with Ashish, or you want, you decide. New unit, new day.
Yes, sir. Next day will be better.
Acha. Okay. No problem. I respect your choice. So we'll start new unit today. So should we close for today? Sorry, tomorrow.
Yes, sir.
Okay, no problem. So you can type your number and you can log out and we'll start new chapter tomorrow. Thank you.